In the previous video, we saw some tools that operating personnel can make use of in addressing quality improvement initiatives in any organization. There are other tools available for management to incorporate quality requirements at the design stage itself, in the product and process planning, and even in strategic planning. So, in this video we shall see some more examples of that category. The first tool is Poka-yoke, which is a Japanese term which means foolproofing or mistake proofing. Basically, it is a technique which works on the basic premise that several defects that creep into an operation are indeed avoidable in the first place. Further, errors and defects have a cause and effect relationship. Therefore, if we have identified the cause, the effect can also be removed by removing the cause. So, Poka-yoke ensures that a defect once detected can be eliminated once and for all by modifying either the process or the design of the product or service. There are plenty of examples in real life. This is one area people can use their imagination with this basic concept and improve quality and put a system of elimination in the first place, prevention and elimination. Look at these popular examples. This is a typical SIM card and you see a certain kind of a shape here. You also see another type of shape here. All these are meant to ensure that this card cannot be inserted wrongly. That is the idea. This is a sort of a mistake proofing. We use this every day in our life. You have this pen drive. Again, if you look at this component of the pen drive, it ensures that it cannot be wrongly loaded, and this is another example. You do not see it, this is inside a computer, this is a RAM, and again these kinds of shapes that you see here indeed point to a certain kind of mistake proofing which has eliminated some avoidable errors of using these sort of a circuit board. So, in this industrial example, what you see here, this is a radial drilling machine. As you see here, this is a rotating wheel. You can rotate it, and if you rotate it, the drilling bit comes down and the through hole is drilled, and if you rotate it the other way, this will travel up. Now, what was happening is the process had defect, in the sense there was no through hole drilled, which they saw when they were assembling the component. So, this is an avoidable defect in the first place. So, how did they do it? They first of all installed two sensors. You see two sensors here. This is sensor 1 and this is sensor 2. So, these two sensors, so this, and there is this contact. This is the contact. This lever that you see here, that is the contact. So, when this wheel is rotating upwards, this will travel and this contact will touch here, and if you rotate it counterclockwise, it will travel down and touch this contact, and it ensures that only after it touches this lower contact, the wheel can be retracted upwards. You use a pair of sensors, that is what you see here, and the pair of sensors control the movement of the rotary wheel, rotary handle let me say, which travels up and down, and it makes sure that a through hole is always drilled, because unless it touches the lower sensor, there is no way you can retract the wheel up, and by the time it touches the lower sensor, I think the through hole is done here. The tool has traveled this far. You also notice something interesting here. You see there is a counter here, because in this process they have to send 100 pieces from time to time. So, earlier they were stopping the process, counting the number of pieces, putting it into a box or a basket or a carousel or something and sending it to the next process. Now, what will happen is every time this lever touches the lower one, the counter will automatically go up by 1. There is a reset button in the counter. So, when it comes to 100, you can reset the button also. So, it also improves productivity. So, there are plenty of examples of this kind we will see in practice which can help us improve quality and productivity.